We're going to start with chapter 9. Chapter 9 is really, the whole thing is about areas. It really is talking mostly about what an area is. Okay, so this whole thing is about areas. We came up with the formulas for different figures. So a rectangle, the area is equal to the length times the width, or it might be said the base times the height, because the base would be your bottom number, the height would be your number that's going up. Okay, so that's our formula for that. A triangle, the area for a triangle is equal to the base times the height divided by 2. Where if you look at a triangle, the height has to form a 90-degree angle. So when we're looking at a height here, the height is a 90-degree or perpendicular amount. So it's the 90-degree there. The base is this number down below. The base is the bottom, and that's your height. That's straight at a 90-degree angle. Okay. For a square, you don't have to memorize this. You can use the rectangle formula, but the area is the length of the side squared. So if you have a square, it's S times S. That's why it's S squared. Okay, for a square. Then we have a parallelogram. The area is the base times the height. Very similar to a rectangle. The only thing when you're looking at a parallelogram is you must make sure your height is that 90-degree angle. And what you're really doing is making it into a rectangle by cutting this off and putting it over here. Okay, so this is your height at the 90-degree angle, and this is your base. Okay, so those are some of the formulas. Then the last one, which you forget quite often, is a trapezoid. The trapezoid, which is one we use quite often, is equal to the base 1 plus the base 2 times the height divided by 2. Okay, so when we're looking at a trapezoid, it could be something like this. Okay. Here would be my height because it forms the 90-degree angle there. Okay, this would be base 1, and this is base 2. So you're adding the parallel sides, the lengths of the parallel sides. Okay, so that's what you're doing in that one. It's the parallel sides that you want to add, not the ones that are not parallel, but you want to add the parallel sides. And then you have to have the height, which is, again, it has to form a right triangle or a 90-degree angle with one of the bases, or with both of the bases actually. So when you're looking at this height, here it needs to form a right angle with both bases. That's your height. Okay. The other thing in this section was basically that you can find an area of an irregular shape. That's a polygon, okay, by just splitting it into triangles and trapezoid or smaller figures. So just add non-overlapping smaller triangles or quadrilaterals. So what that means is you can break it up into rectangles, triangles, squares, anything like that, and then add those up. It's kind of like what you're doing in the review with the origami paper. You're looking at all those and you can just break it up into little pieces. Now that one you could find the area of it regularly because you saw what you started with, but that irregular shape you could have broke into smaller pieces and got that. Okay? That is basically everything in chapter 9. Chapter 9 was just about area. It was just about all those, looking at all of those. Okay? That's what we looked at. I think it did go in, is chapter 9 the one we had Pythagorean theorem in? Yes, chapter 9 is the one we had the Pythagorean theorem because it's talking about the areas, because it's really the areas of each side squared. That's why it's put in there. So the Pythagorean theorem was the only other thing. Now, I will tell you, I will not make you prove the Pythagorean theorem on the test. That will not be on the test, okay? But you should know that a squared plus b squared is equal to c squared. And that basically is when we have a right triangle. It only works with right triangles, where A, it doesn't matter which one's A or B, and C is always the hypotenuse. So to test to see if something is a true right triangle, you can use that. If you're given all three sides, you can see if it really is a true triangle, like what you did up on the boards today, and you found it was 169 versus 170. It truly wasn't a right triangle because it wasn't exactly the same. So you can use this to prove that, or you can use it to find other links. Okay, so that's really chapter 9 in a nutshell. That's what we covered in chapter 9. Okay, so if you know those formulas, have them there for the test. It's very easy. You can look at these formulas on the test and you know what to do. Okay, so let's look at chapter 10 now. What is the whole thing about chapter 10? Chapter 10 is all about similar polygons. Okay, so it's really talking about all polygons that are similar, but similar polygons, one thing we know about them is they have same angle measures. Okay, so their angles all are the same measure as each other. Okay, so both pairs have the same angle measures. Then the ratio between the sides is constant. Okay. An example, I'm just going to use a right triangle because it's easier. Okay, so in here, we know that all these angles are the same. That's the markings there. All the angles are the same. Okay, and then if I call this 3, 4, 5, and I do this as 9, 15, and 12. Okay, notice the ratio of the sides are the same. 12 to 4 will equal 9 to 3, which equals 15 to 5. So if you look at this, this is 3, this is 3, this is 3, check. The ratios are all the same, So this is a similar triangle. Same thing with squares, if they have all the same ratios, or if you're told they're similar, then you know all the ratios are the same. Okay, so that's basically the first part that we talked about. We talked about how to solve a proportion. What are some of the other things we covered in here? I have to just see. Oh, yeah, we talked about if we have a right triangle like this, or is it any triangle? No, it's a right triangle. And if I cut it like that, it cuts them into similar triangles so that the large triangle is similar to the smaller.
Doesn't it create a trapezoid?
It creates a trapezoid
okay.
here, but if you think of the large outside one, so kind of like the
Okay.
large triangle and the small one, they are, and these are parallel, okay? So they have to be parallel, so this is one thing you need to know is they're parallel. Okay. So that's something, it's called the side splitter, but we don't really care about that. Because it splits them into equal ratios is what it does. Okay. So that's just basically, it splits into two similar triangles. Okay. The next thing we looked at was again, triangles. In a triangle, or triangles, if two triangles have two angles the same, then they are similar. So basically, if you know that two angles in a triangle are identical, or two triangles are identical, so if two triangles have two angles the same, then they are similar. That's what that tells us. Okay, so that's called the AAA theorem. I don't care if you know that. I just want you to know if you have two of them the same, the third one's going to be the same. So that makes sense. That's why it's the same. Okay. Then the next thing was there's a dilation, so dilation is basically you can do it to small to large or large to small. So it's kind of, that's how much bigger it is. The dilation is just how much are you multiplying it by or changing it by. It's really the proportion of the small triangle to the large triangle or the large to the small. And when you're writing them, so if it is 34 to 70, how about 68? That'll be easier. 68. 34 to 68 means we're going 68 divided by 34. So the first number is on the bottom. So that was the thing that was, it's different if we're going from 68 to 34. We're making it smaller, so we take 34 and divide it by 68. Okay, so again, the first number is on the bottom. So this is equal to 2. This is equal to its reciprocal, 1/2. Okay, so that's basically what we kind of went over today in dilations. We looked at that. Okay. The last thing that we did in here was the perimeter of similar triangles or similar figures is in the same ratio And the area of similar figures is in the ratio squared. Okay, so what that means is if my perimeter, so we have a 1-to-2 ratio, that's my ratio between two figures, okay? If I have, the perimeter is 30 here, the perimeter here would be 60. It's still in that same one. This is 1 and this is 2. But my area, if my area is 15 here, I have to square this. So it would be 1-to-4 because r squared is 1-to-4. So I would take this times 4 to get my larger area. So it would be 15 times 4, which is also 60. Okay, so that's the difference. This is perimeter, this is area. Okay, so 1-to-2, it stays in that same ratio, but for the area, the ratio is squared, so you square them, take 1/2 and square it. And so it's 1-to-4, so I would have to make it that bigger. Okay, does that kind of make sense there? It doubles, it squares it. Okay, so that was the last section that we went in. You just have everything you need for your notes that we went through in those chapters. Okay, so keep that handy. You will have a test next week at home that you'll have to do. And then we are going to do our report next Tuesday in class about Pythagorean theorem.
Oh, it's not Tuesday.
Till next Tuesday,
What do you mean report?
you're going to do a report and show your Pythagorean theorem that you looked at.
So, Katie, are you just reading off the paper?
You're just going to